All right, let's do some answers. So, it's everywhere. All right, achieved level stuff I will write in red pen. Merit level stuff I will write in blue pen. And excellence level stuff I will do in green pen. The other thing I will do is I will write, let's do purple. I like purple. Stuff in purple is just to show process. So just basically how I decode a question and pull information. Does that sound like a good idea? I think some of you guys just need to understand how to decode it. All right. On top of that, you guys should have this resource sheet. Be mindful that I've listed the redox pairs in alphabetical order. Mr. Graham and I are, or I should actually say, Mr. Graham is working on reorganizing this so that way it's based off of reduction potential instead. And if he does do that before the internal, I'll print out the new version and I'll show you guys how to find things. But I'll show you guys how to find things this way as well in case both ways kind of work. The other thing that I've given is a checklist. The checklist is really useful because it gives you guidelines of what you need to be able to do, but this bottom bit here on the assessment requirements is useful because then you know what you need to do for achieve, merit, and excellence. The other thing that I've printed out as like a generic kind of thing to look at is a marking schedule. This is from the practice internal that I gave you guys, I think probably, what was it? Week 8 of last term. So this practice redox test is online and the marking schedule is also online. The reason why I printed it out is because I wanted to use it as a reference point so you guys know exactly how you're going to be assessed and the format of this assessment. So some things to note about this assessment. You see how it says 2 out of 3, 2 out of 3, 2 out of 3? You are going to get 3 questions like this. I will remove the practical component so it's all just a theory test and you'll be getting 3 questions combining 2 different reagents together and doing a redox reaction. With the marking and how the points are going to get divvied up, you need to get the majority, so 2 out of 3. So you got to basically pass 2 questions to get an achieve for this assessment. It's obviously going to be the lowest thing. So if you get 2 merits and 1 excellence, you're going to get a merit. Does that make sense to you guys? Anyway, I'll use this as a reference point so that way you guys can also see how I mark something to the achieve, to the merit, to the excellence, and where you're going to kind of potentially lose points. Are we good with that so far? All right, so let's start with the question so we know how we can pull information from it. So first thing I'm looking at here is that it says that we are taking sulfur dioxide, which is a colorless gas, and we are bubbling that through a solution of iron 3 chloride. So what I suggest you do before you start even kind of writing is you take a moment to think about what reagents have they given me, so that way I can identify oxidant and reductant and things like that. Actually, let's do some easy stuff first. So some stuff for the achieve that you need to be able to do is just show that you know vocabulary. So we can see here on our checklist, can you link oxidation or reduction to gaining or losing electrons or increasing or decreasing oxidation numbers? So before we even start looking at the question, let's drop down our vocabulary to show that we can meet that requirement. It's also on the checklist over here, links oxidation or reduction to increase, decrease oxidation number or losing, gaining of electrons. Are we good with that so far? So the word oxidant is not referring to the oxidation reaction, it's referring to what is it doing to the other half of the equation. So if I am an oxidant, I am doing the reduction reaction. Are you okay with that so far? If I am a reductant, I am doing the oxidation reaction. So and we good? The other thing that we need to do for the achieved is putting in our definitions. So for a reduction reaction, remember that we're thinking about Leo the lion says grr. So since this is the reduction reaction, there's 2 different ways I can define it. The first way I can define it is that it has gained electrons. Or I could say that the oxidation number has decreased. It is an or option for the achieved. So long as you make one of those statements, you are fine. Are we good so far? All right, with the oxidation reaction then, Leo, loss of electrons. So this guy has lost electrons. This one is the oxidation number has increased. Remember that the electrons are negative. So if I lose electrons, I'm losing that negative value, so my oxidation number increases. Again, this is an or option. So the other thing I need for achieved is your definitions. So this is generic stuff. I haven't even looked at the reagents they've given me. I'm just dropping down my vocabulary. Are we good so far? So if I'm looking at a checklist right here, links oxidation or reduction to the oxidation number or the electron number. By doing that, I've met that achieve requirement for one of my questions. Cool? Same thing when I'm looking at this checklist over here, link oxidation or reduction. Just basically, can you regurgitate the vocabulary? Are we good so far? All right. Next thing I need to do to get to the achieved is I need to take these reagents and I need to figure out what's going on. So I'm going to take my resource sheet and I'm going to list out everybody that I have, and I'm going to be thinking about what is it going to become. You're going to be using two things. First off, the reagents that they've given you, the comparison of like all these different observations, and then their redox pair as well. So I'm going to write them all down. So the first one is sulfur dioxide. I have SO2, and that is a colorless gas. I have iron chloride. So if I have iron chloride, if I look at this thing, it says iron 3. So that's a 3+. If I look at iron 3 on my list here, I see that's a pale orange. Now, it's going to be a very, very pale orange. You may not even be able to see it. All right? The last thing listed is they tell me I have chloride. And if I look for chloride on my list, it is colorless as well. These two are an ionic compound, so I'm only choosing one of those two. This one I have to use because it's the only reagent of that second list. Are you okay with that so far? All right, now what I want to do is I want to look at them under this redox pair list. If something's going forward, that is the reduction reaction. So all of these are ordered in the reduction reaction. However, we know with redox, I have to have one oxidation and one reduction. So if I go in reverse, that's going to be my oxidation reaction. Are we okay with that so far? All right. So let's try to find all three things on the list and try to figure out which one's the oxidation, which one's the reduction, and how we're going to pair them up. Basically, what I'm trying to figure out is which ones are spectators, because if they're a spectator, I can ignore it. Okay? So here's chlorine and chloride. I want the chloride ion. If I keep looking down the list, here's my iron 3. And then if I keep looking down my list, here's the sulfur dioxide. Are we okay with that so far? All right. I have two things that are reductants that are going in the oxidation direction. I have one thing that is going this way, and that's my reduction reaction and the oxidant. So which one automatically do I know is going to be the oxidant? The iron 3, because it's the only one on that list. So that's what I'm going to put down as my oxidant. If I look at that resource sheet, I can see what iron 3 is becoming. What is it becoming? Iron 2. So the product for that is iron 2. You guys should be writing things down, then. I'm spoon feeding you the answer. Are we okay with that so far? All right. Now let's go back and look at that resource sheet. So I already have my oxidant. Now I need to pick an reductant. I have these two as my choices. The one I'm going to take is going to be the sulfur dioxide. The reason why I'm taking this one instead of the chloride is because I need to take one from each reagent. So since I've already taken the iron 3, I can't use the chloride. Besides, if I was going to use the chloride, it would auto redox itself. Does that make sense to everybody? So I'm canceling out the chloride. We're not using the chloride. We're definitely using this guy. Cool. You should always have one from each side. If you have two on the same side and you're using it for your redox reaction, you have two reduction reactions, or you have two oxidation reactions. So you're looking at opposite sides of this table. Are we good so far? All right, so I have SO2, the product for that, when I look at it, going this way, SO4. We good so far? And then the reductant is SO2. Cool? Looking at that checklist then, the second requirement is you need to identify which reaction's oxidation and which one's reduction. I've done that. Same thing here when I'm looking at this checklist, identifying, the direction of what's happening. So this was bromine getting reduced and copper getting oxidized. Basically the same thing. It's basically this component here. Are we good so far? Cameron? Cool? All right. The last thing you need to do for the achieved is you need to state observations. All right? So you are just stating what you see up here. So we see that there's a gas being bubbled and the color change is from pale orange to pale green. In fact, I have given you the achieved answer there. We just write it down in here and we link it to the species. Okay? So, colorless gas, SO2, is bubbled into an orange, or I should say pale orange, and I can't spell orange, solution. What's causing that pale orange color? The iron 3. Again, we can look at the list. I see iron 3, that's the pale orange. I know I'm forming iron 2, so what color should it turn? Pale green. Again, tell me into a pale orange solution, which turns a pale green. Which is iron 2. Cool? All right, that requirement is done. Looking at this, have I stated the observations? That's all you need to do for the achieved. You've passed and gotten 3 credits. All right? Most of it is just regurgitation, because this bit all down here, that's just vocabulary. The only thing you then need to do is use this sheet and figure out what's happening. Are we good so far? All right. Let's move on to the merit and the excellence. I might actually talk about things to the excellence level because a lot of the merit is just you've made a mistake somewhere. Very similar to other things that you guys have seen before. So I'll go through it at the excellence level and then I'll backtrack and note where the merit points are. So when we're looking at this kind of checklist here, actually I might show you guys the resource sheet first. When we're looking at this bit here, merit is being able to do half equations, and you only need to do one of them. Whereas excellence is both of the half equations and the full equation. So it's just a little small step up to get to the excellence. The biggest jump is from achieved to merit. The other thing you need to do for the merit is linking with more detail. So giving me specific number of electron transfers, giving me specific change in oxidation numbers. Now this is an OR. So long as you do one of the two correctly, so either you've done the oxidation correctly or you've done the reduction correctly. What this means is you can make a mistake and you can still get merit. Are we good so far? All right. What I might do is I'll show you guys the easy equations first, so you can see how you get an easy merit, and then I'll layer in the excellence. Does that sound like a good plan? All right. If I wanted to get an easy merit, I will be checking ions, because ions are very easy to do half equations for. They're also very easy to talk about gain and loss of electrons. Okay? So, when I'm looking at this and I'm looking at the charge, it's gone from positive 3 to positive 2. So what has happened here is that I have gained an electron to lose that one number. So I would just state you have gained one electron. The oxidation number has decreased by 1. So what we have seen it go from as positive 3 to positive 2. All right? You need to have justifications. So with looking at that requirement, it says, can you link the oxidation or reduction to the correct number of electron transfers? I said 1 electron. You met that requirement. Next one. Can I link the oxidation or reduction reaction to change of oxidation numbers? I have. I've said it's gone from positive 3 to positive 2. Reduced by 1. Cool. Last thing I need to do then is balance a half equation. So with this nice easy ion 1, I'm going from iron 3 plus to iron 2 plus. Yeah? It has gained an electron. So since it's gained an electron, the electron will be on the reactant side because it's being added to that iron. And there's only 1 there. That's done. Now I'm at a merit. I've completely forgot to write this guy, and that's fine. That's all I need to do for a merit because it's just an OR option here. So again, it's OR in this way. So either you've done the oxidant correctly or you've done the reductant correctly. It allows you then to make a mistake. Most people get merit because they've made a mistake. Are we good so far? All right. So, cool. For the excellence then, you can get these guys as well. This one I find is probably a bit harder. So usually if you're getting this ones with the balancing of oxygens and things like that, you're probably at the excellence level. I'm trying to decide if I should do it in blue or green. I might do it in blue so you guys can see it and then show you guys the excellence with the green. Okay. So what I need to keep in mind when I'm doing this, I might actually start with the equation because I think the equation then makes it a little bit easier for me to do oxidation numbers and electron gain and loss. So I have SO2 becoming SO4. 2 minus. Sorry, forgot the charge on there. All right. There are specific video lessons that I have explaining how to balance equations, and I also have specific video lessons explaining how to find oxidation numbers. I'm just going to breeze through it because you guys can watch that on your own time, okay? I just want to show you guys how to do this assessment. So, first thing I look at is have I balanced the active species in this, which is going to be the sulfur. I see sulfur is 1 on both sides, so I can leave it alone. The next thing I check is oxygen. So I see that's 2 and that's 4. The way I balance for oxygen is by adding water. So in this case, I am short by 2 oxygens, so I am going to add 2 waters on this side. Is everybody okay with that? All right. Now, I've added a problem into this. Now that I've added water, I have added hydrogen to my equation. So I need to balance for the hydrogen. The way I balance for my hydrogen is by adding hydrogen ions. So in this case, there's 2 times 2. So that makes it 4 hydrogen ions that I'm adding. Does that make sense to everybody? All right. The last thing I'm going to check then is the charges on both sides, because on both sides of the equation, the net charge needs to be the same. So I'm just looking at the charges of the ions to figure that out, to add my electrons. So this is a molecule. There's no charge to molecules. This is also a molecule. There's no charge to molecule. What this tells me, though, is that on this side of the equation, the net is 0. Are we good so far? All right. This side of the equation, I have an ion that has a negative 2. I have an ion that's a positive 1, but I have 4 of those. So positive 4, negative 2. Total charge on this side is negative 2. Sorry, positive 2. My bad. Are we good with that so far? All right. In order to balance the charge, I'm going to add electrons. Now, I can, with the electrons, they are negative, so it's going to bring the higher number down. So I'm looking at these two, looking at which is the higher number and bringing it down to match the other side. So so you don't necessarily need to get to 0, you just need to get to the same number. So since this is positive 2 and I want to go down to 0, I am adding 2 electrons here. Cool? Quick things to check to make sure you haven't mucked up. Electrons should be on opposite sides of the equation because they will cancel out when we're putting the equations together. The other thing is that since this is the oxidation reaction, I should be losing electrons, and losing electrons will be on the product side. Okay? These are things to double and triple check. Now that I have that, I can actually include this into my answer. Now be mindful that whenever we're talking about it in reference to one atom. In this case, this is in reference to one atom. But if you had, for example, dichromate, that's 2 chromium atoms. So you just have to be mindful, you got to divide that by 2. So when it comes to lost electrons, I have lost 2 electrons. So now I can be specific. The oxidation number has increased by 2. Now, oxidation math, you guys are going to have to double check. I'm not going to go through oxidation numbers, but just to state, this sulfur is positive 4, and it's going to become positive 6. If you don't know how I did that, go watch the lesson on oxidation numbers, because I'm not going to explain it right now. Cool? All right, last thing then for the excellence. So keep in mind some things. First off, for the excellence, you need to have both justifications. So instead of being an or choice, it's an and. So you need both of them. The other thing is that we need to you need both of these equations for the excellence. And then the last thing is you need to put these equations together for a full equation. The way I put it together for a full equation is that I check the electron numbers and I need them to match. This is 2 and this is 1. So I need to multiply this whole equation by 2. So I'm going to do that, put my 2's in front. You good? Last step then is I go through and I cancel out what's on the opposite sides. It's useful if you line up the arrows, because when you line up the arrows, it makes it very clear what's reactant and what's product, and then you can check to see, are they on opposite sides? Are they going to cancel out? If they are on opposite sides but they don't cancel out, say for example with hydrogen ions or water, you just subtract it away, and so one side becomes 0 and the other is whatever's left over. Cool. So in this case, those electrons cancel out. I look for water. There's no water on that side. I look for the hydrogen ion. There's no hydrogen ion on that side, so both of those guys get to stay, and these guys will probably stay anyway. It's very unlikely you're going to cancel those out. You're mainly looking to cancel out the electrons, the hydrogens, and the waters. Cool? Then I put it all together. Doesn't matter what order you guys write these in, so long they're on the right side of the equation. Oops, that's a 2. And that's my full equation. That's gotten me up to the excellence level. There's lots of different videos online. There's lots of different work online depending on what you need to work on. This format of writing everything down and answering it to that level, that is the last lesson that I posted, and that was in week 8. In fact, I might pull up the stuff on the video. Anyway, just checking that off. So that's all done. If we're looking at this marking schedule here, one of the half equations links oxidation or reduction to the electron number, transfer with the number, links oxidation or reduction to the oxidation number, so that's all good. For the excellence, both half equations, full equation, and then both oxidation and reduction with the electron and the oxidation numbers. Cool? All right. So that's all this assessment is. You get 3 questions like that to do in an hour. I'll pull up the resources online just so you guys can see it. And you guys know what is there so you guys know how to revise. It's a really easy assessment. You just need to practice. All right? So here's my website. We're going to level 2 chemistry. We're going to Redox. All right, here's some of the stuff that I posted online. Assessment template, if you guys want that. I've printed out some copies. I have enough for each person to take 2. There's also the resource sheet there. I have the 2021 lessons, so this is the ones that I designed for lockdown, but you're welcome to look at the stuff that I did for in-person teaching as well. It's a slightly different order and a slightly different pairing. But you can pick things based on what you need to have worked on. So let's say the oxidation numbers, you know how very quickly I went through it, and you're like, I don't know how you got those oxidation numbers. I have a lesson just on that and just for that to practice. Hello, Grace.
If we only watch the 2021 video.
Yes, 100%. Yeah, you'll be fine. The lesson number 3 is also good for oxidation numbers because it teaches you how to use them in equations, which is what I was kind of looking at. Let's say you're fine with oxidation numbers, you're fine with the vocab, but you're not good at balancing equations. So there's a lesson there just to practice balancing equations. And then lesson number 5 is putting everything together. Right? Depending on your goals is going to affect what sort of work you're doing. If you're only aiming for the achieved, you're probably fine just doing the vocabulary and the assessment format and just answering the assessment format to the achieved level. If you're trying to get merit or excellence, you really then need to go through the oxidation numbers and the equations. Are we good so far with that? All right. Like I said, it's a really easy assessment. I think it's just a matter of practicing and memorizing things. The other thing to kind of keep in mind is that when you guys are writing charges, the sign goes after the number, but when you're writing oxidation numbers, the charges go before the number. So just watch that. It's just chemistry language. Cool? So on Friday, I'll give you 3 questions like this, and it's the majority. That's all I got to do. All right? Any questions? All right, you have about 15 minutes, so feel free to get some study done. I'll put these, should I pass out these sheets? There's 2, and it's double-sided, so you get 4 chances to practice. I'm happy to look at any work and to give you feedback on it, because it is one of those assessments that it's kind of like ion identification. You make a silly mistake, and it kind of really mucks it up. I will scan all these and put them online, too.